In this video, I will talk about all the decisions I made before starting the fabrication. Instead of starting my project by building it, I searched the specs needed to accomplish my goal, which is Mont Bellevue. Without these informations, I cannot start the design phase. I will also explain the ideas that I had and the reason why I chose a certain one. In total, I made 26 versions before starting the fabrication. My decisions were based on three main factors. It has to be electric, the frame needs to be made out of broken hockey sticks, and I have to use as much parts possible from this electrical scooter. The more components I can salvage, the less time and money I'll have to spend on new parts. My previous version was using a 36-volt system and could go up to 30 km an hour or 18 miles per hour. The torque was just enough to make a 150-pound person go on a flat road at a standstill. There are three variables when choosing a battery: the voltage, the BMS in the cell, and the capacity. A higher voltage will give a better acceleration and a better top speed. The BMS in the cell limits the maximum current that the battery can output. A higher current will give more power and more torque. A higher capacity will increase the range. Since batteries are quite expensive, it's important to choose those variables quite carefully. I know I want to go faster, and I need a lot of torque to go up a mountain. Normally, e-bike batteries are 36 volt or 48 volt. There are also 52 volt batteries that can give a little bit more power. After looking and shopping on the internet, I found a good battery that is powerful enough and that has a good price to quality ratio. It is a 52 volt e-bike battery with a 40 amp BMS and a 20 amp hour capacity. This battery will provide more power than I really need, but I will need this power for future project. While looking for the battery, I was also looking for a motor. For the motor and the battery to be compatible, the motor needs to take less current than what the battery can provide, otherwise it can damage the battery. Using Ohm's law, we can determine that 52 volt times 40 amp give around 2000 watts. Technically, it's a little bit more complicated since the battery ranges from 58.8 volt when full and 39.9 volt when empty, which ranges from around 2350 watts to 1600 watts. These calculations were made at 40 amp, which the motor will not always need. This amount of current is needed when going full throttle and up an incline. For the motor, I chose a 48 volt brushless motor capable of outputting 1800 watts. This is contradictory to what I said earlier, since 1800 watts is bigger than 1600 watts, which could damage the battery. I will adjust the gearing to get a good ratio of torque and speed at the wheel, and I won't be doing full throttle all the time. The motor also comes with a speed controller that takes a maximum of 33 amp. So technically, the battery will never have to output 40 amp. From what I saw on the internet, 1800 watts is way much more than I need. If I want more speed, I will adjust the gearing. For the direction, I started by making a CAD of the electric scooter. I can reuse the suspension, the handlebar, the tires, and the brakes. There are two problems with the direction. First, the distance from the wheel axle to the pivot is too short. This would have given Project Slapshot the look of a speed bike instead of a motocross. Increasing this dimension will also give a better turn radius. This means I have to find a replacement for the side plates. At first, I wanted to use aluminum tubing to replace them. But I don't have the equipment to make the flat at the end of the tubing for the axle. I decided to do it with hockey sticks, but I had two major concerns. First, I am afraid that with constant use, the bolt holes will grow larger over time. Second, if there is a side impact after a jump, I am afraid that this will weaken the direction. After some thinking, I decided to reinforce the hockey sticks with aluminum on the side to prevent the holes wearing out. I also decided to put a stick in the middle of the direction to prevent any twisting force. I also want to add a front brake, but I will be doing it while building the project since some dimension will change. My first pocket bike was made out of aluminum. It was more solid than what I needed, and it was what I had on hand. The frame of Project Slapshot will be made from broken hockey sticks for two main reasons. First, this bike will be larger than the previous one, so it will be heavier. Using a 52 volt battery and an 1800 watts brushless motor, we'll add around 25 pounds. All the parts I use from the electric scooter are made of steel, which is quite heavy. To minimize the weight, composite materials will be great. The second reason why I want to make it from hockey sticks is just because it looks cool. The frame will be the foundation of many components. It will need pegs. The propulsion and the direction assembly attaches to the frame. The angle of the seat should not be irritating for the rider. The battery monitor should be visible. There should be place for all the electronics. And the battery has to be secure. For the main architecture, I decided to go with this shape for two reasons. If the rider has to go on their feet, his weight will redistribute over the entire frame since it is connected to the center stick. The same logic applies to the seat. The center stick is connected on this hand, which means the torque created by the weight of the rider will distribute over the entire frame instead of just this length. To fix the frame together, I will be using laser-cut aluminum reinforcements, steel corners, and rivets. At first, I wanted to use bolts, but I think it would implement too much play in the frame. Rivets, on the other hand, causes almost no play since it snaps into compression. I also decided to 3D print the fenders, the battery monitor support, the ESC cover, the direction and propulsion aesthetics, and the pegs. To make sure the rider's feet will be secure on the pegs, I threaded 25 set screws in each pegs. The seat of the first pocket bike was atrocious. Riding it for more than 10 minutes was literally a pain in the ass. So, if I want to ride for longer periods, I will need to make a better seat. For the propulsion assembly, there isn't too much change. At first, I wanted to place the motor under the brace because I thought it would give me more suspension travel, but in the end, it just gave me more problems. Since the electric scooter used the same motor format that I bought, everything was gonna fit perfectly. The only thing I had to look for was how I was gonna attach the propulsion assembly to the frame. I decided to use rivet nuts and bolts. The rivet nut would be clamped in the hockey sticks and the propulsion assembly would bolt itself to them. I later discovered that this would cause serious problems, which you will see in the next videos. You should subscribe if you want to see the finale of this project. I made all those decisions from previous experience and by talking to a lot of people. Some of these people are engineers and some others are my friends. If one of you think of something that could make this project better, please leave a comment. I really want to hear about it to learn as much as possible. In the next video, I will start the fabrication. If you want to help me, a like and a subscribe will be much appreciated. Until then, see you next time.